Hello everyone. In continuation to our lecture yesterday, rather on Saturday, we were doing a few more questions. We were doing questions based on nodal analysis. Today, we we will do two more lectures. We will do two more topics. Rather, we'll do in particular we'll do nodal analysis itself. But there's only one variation. As of now, we were doing only independent sources, right? Today, today we'll be working upon dependent sources. Okay. Now, what is the difference between an independent source and a dependent source? Rather, let me explain what is a dependent source. A dependent source of energy is any source of energy given in a circuit which derives its source of energy from another part of the circuit. See, in in general, there are four kinds of dependent voltage sources. What are those? See, how do you know what kind of uh, uh, what kind of energy sources they are? Let me just write them down for you, and then we'll see how to name such sources. One is voltage controlled voltage source. Another is voltage controlled current source. Another is current controlled voltage source. And the last category would be current controlled current source. Okay. So these are the four types of dependent sources. Now let me tell you how to define what kind of voltage source or what kind of source a given particular thing is. Okay. So one, you need to realize what is the symbol given here. Okay. So what is the symbol given here? That would tell you what kind of source it is. For example, in this case, the first case, see, it is the magnitude, the symbol given here is plus minus, which means what it is? It is a voltage source. Okay. Here, the symbol given is a direction of current. What would it be? This in the second case, it would be a current source. In third case, what is the symbol given? It is a plus minus sign. So it would be a voltage source. Similarly, the last case would be a current source. So these are the kind of sources. But let me tell you what by what it is controlled. How would you find that? See, for any value given as dependent source, you'll be provided with something of this sort. See, V is equals to K times V1. This is something that you will be given. Now the parameter which defines the voltage V, the parameter which defines the voltage V, or probably the value of the energy source, is known as the controlling parameters. So in this case, what would this be? It would be a voltage controlled voltage source. Why is it a voltage source? Because the symbol is given to be plus minus. Why is it voltage controlled? Because the voltage is defined in terms of another voltage in a given particular circuit. Okay. Similarly, what would this be? This would be a voltage controlled current source. Again, I am repeating. Why would this be a current source? It would be a current source because it is the symbol shown here is a symbol of current, right? Voltage and and why is it voltage controlled? It is voltage controlled because it is voltage controlled because this parameter which is the controlling parameter is a voltage parameter which governs the current in the given current source. Similarly, what would this be? It is a current controlled voltage source. This one is a current controlled current source. It is a current source as the figure shows. It is a current controlled parameter because the current I in this source is dependent on another current I4, and hence it is current controlled. Here it is current controlled voltage source. Why? Because this is a voltage source and the voltage V is dependent on some value of current I. Is it clear? Generally, the these are linearly these are linearly dependent sources. So generally, what would you find? You would find this this controlling parameters with the index of 1, right? So only then it would be linear. Otherwise, if it is twice, then what? Then it won't be a linear parameter, right? So generally they are linearly dependent sources. Maximum you'll find such values. Like maximum you'll find such sources in your questions. Okay? So today in our today's lecture we'll be taking a few more questions again based on what? Nodal analysis, but this time our sources would be dependent sources. Okay? So this is your question number 1 for today. Just take a look and see, just take a look and see what kind of source is given to you in the question. What kind of source is given to you in the question? See, what is the symbol given here? What is the symbol given here? It is plus minus. So can I say it is a voltage source? Right? It is a voltage source. Now, what it is dependent on? It is 2.5 times of I. What is I? I is the current flowing in this branch. So, it is dependent on some current. Or in other words, can I say this voltage source is controlled by the current flowing in this branch. So, can I say it is a current controlled voltage source, right? See, today we are doing just a few questions on nodal analysis. I want you to understand that as you progress and as you do questions also on your own, these are only a few questions that we'll be doing together. If you do a lot of questions on your own, you will realize, and you can, you know, when you're attempting any question, right, then you can understand which approach to use for a question. For example, in this case we're using nodal analysis. Why? Because you'll find a lot of nodes here. Generally, wherever you find a lot of nodes, it is easier to you know approach a question using nodal analysis. Once you're once you begin practicing these questions for then you'll be very then this these questions would be very easy for you. Okay, so tell me, how many nodes do you see in these questions, and how many nodes can you determine the uh, voltage at? See, this is ground, right? And this one is already defined to be what? V2. This one is defined to be V2, right? This one is defined to be V1, right? Now, do you see any other node in this question? There will be one node here, and this node again is continued till here. So this is what? This is this node. This node is right here because it is connected through a thread conducting wire. So it will be short circuit. So the same potential from here to here. So node will be 1. What is the value here? It should be 30 volt, right? From ground there is plus 30 volt potential here, right? V2 is already defined for you in the question, and V1 is already defined. Now looking at the question, tell me what is the value of V2? What is the value of V2? See, can I write V2 to be equal to 2.5 times I? See, this is ground from negative to positive, yani this would be what? This is at a higher potential. So V2 is at what? 2.5 I times higher potential at from the ground. So can I write V2 is equals to 2.5 I? Right? Now tell me what is I? What is I? Current is flowing from this potential to this potential. So what would I write? 0 minus V1, right? Divided by what? What is the resistance encountered? 3 ohms. This is what? The value of current I, right? Right? So can I write this to be as minus minus 5 by 6 times V1, that it is what? V2, right? Now apply KCL at node V1. Apply KCL at node V1. See, we are assuming all currents to be what? Outgoing. What are the three currents here? This is minus I1. This we'll find out and this we'll find out. Let's begin one by one. I am writing the current in 2 ohm resistor. And please remember, these are all what? Outgoing currents. So you have to take the magnitudes accordingly. Okay? Plus current in the 4 ohm resistor equals to 0. Can I write this? Right? Okay. Tell me what is the current in 2 ohm resistor. Outgoing current, so V1 would be at higher potential, current flows from higher to lower, right? So V1 minus 30, see, this is V1, what is the next potential? It is 30 divided by what? 2 plus, what is the current in 3 ohm resistor? V1 minus 0 divided by what? 3 plus what is the current in the I4 resistor, in the 4 ohm resistor? V1 minus, what is V2? V2 is this, V1 minus V2 I should write, but what is V2? Already we have calculated it to be 5 by 6 times V1, right? Upon what? 4 is equal to what? 0, right? Right? Let us solve this one here. It should be what? V1 plus 5 by 6. V1, what is that? 11 by 6 into 4, right? Times V1. Am I correct? Tell me, am I correct? This is your food. Sorry. Okay. This would be your V1 by 3, right? And this is what? V1 by 2, right? Is equal to what? Minus, here what it would, what you will get 15. 15 I'm transferring to the right hand side, it would become minus 15 would become plus 15. So this is what your final equation comes out to be, which we will be solving for our solution. Okay. To solve this, what would you do? How would you approach this question? We'll multiply the entire equation by what? 24. Okay. So if I multiply it with 24, if I multiply it with 24, what would I get? 12 V1 plus 18 8 V1 plus 11 V1 is equals to what? 15 into 24, right? Tell me 8, this would make it what? Uh, 20, 23, 23 and 8 would be 31, right? Right. So your V1 comes out to be what? Your V1 comes out to be 15 into 24 divided by 31 volts, right? But tell me, what was the question asking you? The question is asking you to determine I. And what was I? What is I? It is minus 5 by 6 times V1. Rather, it is minus, I'm sorry. What is I? What is I? Tell me. I is minus V1 by 3, right? That is what we had replaced here, right? So, so in this case, in this case, what would I be? I is equals to what? Minus V1 by 3, right? Is equals to what? Minus 1 by 3 times what? 15 into 24 divided by 31, right? So what would your answer be? Use your calculators and do it, in case you're, in your case for now. I don't know if you're allowed with calculators in at your whatever exams you're preparing for, but I think virtual calculators are allowed these days in at least GATE examination, that I'm very sure of. Not sure about NET, but in GATE for sure we have virtual calculators. So this comes out to be your answer. See, uh, I'll repeat just the steps for you in this question, so that if next time whenever you encounter any question based on a dependent source, first remember how to identify a dependent source. How would you identify a dependent source? A dependent source is a source usually depicted as a rhombus kind of structure. Then there'll be a value given beside it which will tell on what value it on by which value it is controlled. See, in this case it was controlled by the current flowing in the 3 ohm branch, right? And this is the direction of the current is given to be this. Be very clear about the directions of currents because this is where we usually make mistakes. As a rule, at any node, whenever you're applying nodal analysis, make sure you use all the make sure you determine all the outgoing currents, the sum of all outgoing currents to be 0. So when you follow only strictly one rule, then you're prone to make less mistakes. You're prone to less mistakes. Okay. Okay. In this case, the first thing we determined was what kind of voltage source is given to you in the question. We determined that it is a current controlled voltage source. Then we determined the value of the voltage source using the controlling parameter. The controlling parameter here was current, and we determined the value of current from here. Okay, and then we resolved our question completely into a one variable, that was V1. From here we got V1. I1 was calculated to be minus V1 times 3, and hence we got our answer to be minus 3.870 amperes. Okay, so this is how you approach such questions. Okay. Okay. Next, again we'll be taking a question based on what? A dependent source. Now this time, look carefully and tell me, look carefully and tell me what kind of voltage source is given to you in the question. I'm sorry, this is not VA, this is Vx. Let me just amend it for you. It is what? Vx. Now, look at the voltage, look at the source, dependent source, and tell me what kind of source is given to you in the question. Okay. First thing, it is a current source. How can you say it is a current source? It is a current source because the symbol within it is a symbol of current. It is a voltage controlled current source. How can you say that? We can say it voltage controlled current source. Why? Current source we know because the symbol is the symbol of current. Now it is dependent on the voltage Vx. What is the voltage Vx? It is the potential difference across the resistance R with the polarity as shown in the figure. So this value of current is a dependent value. It is not a constant value. It depends on what? The potential across resistor 1 with the polarity as shown in the figure. Right? So it is what? It is a voltage controlled current source. Right? Right? Okay. So now, for now, let us determine the nodes in this question. Okay, tell me what is the potential at this point? We are at ground and then we are further falling by a potential of what? 4 volts. So what would be the potential here? Minus 4 volt, right? Now I am traversing from this point again to this. I see there is an element. Whenever you encounter element, it is a node. Okay, so can I write this to be a node? Yes, this would be a node. This node is the same as node here because it is a thick conducting wire, right? You can pick this conductor and redraw it to be here. So this is the same point. So what would be the potential here? Let us call this potential to be what? Let us call it P. We just gave it a name P. Okay. Now this is again the same potential, so no problem. What is the potential here? Again it would be a node because we encounter any element, and this would be what? 6 volts, right? Because the potential there is a battery of 6 volts here, right? Right? Now, now, what is the potential at this point? What is the potential at this point? Tell me. It would be 5 volts more than the potential at this point. So it would be 1 volt here. Right? Right? Okay. So this is something that we have. Okay. So let's approach the question now. Right? Right? Okay. So now we know we see a lot of nodes here, right? A node here and a lot of branches here, right? So what do we know from KCL? We will assume all currents to be what? Outgoing. The simple basic funda assume all currents to be what? Outgoing. So what are the currents here that we need to look into? One current would be this, one current would be this, one current is this, one current is this, right? So there are total 4 currents here, right? But we are not sure of the current in this branch. Why? Because it is dependent on this, right? So let us find out what is the potential Vx here. Can I say, what is Vx? Vx is what? If this is Vx, is it not equal to Vp? See, what is Vx? Vx is the potential across 1 ohm resistor. But is this potential not equal to this? These are what? Two parallel points. When they are two parallel points, and these are two parallel points, the potential would be same. So can I write Vx is equals to what? Vp, right? This is the first thing you derive. Now, now at point P, assuming all currents to be what? Outgoing. Assuming all currents to be what? Outgoing. Let us write the values of current. It is at higher potential. This is lower potential. What would be the current in this branch? It would be what? Vp divided by 1, right? Plus, what would be this current? This would be Vp minus 6 divided by 1, right? Now, what did I tell you? What is Vx? What is Vx? Vx is Vp. Vx is Vp. right? And the current in this branch, because it is a current source, do I need to find out any other current when the current is already defined? Because it is what? It is a current source, so there is only, it is in series, so there will be only one current flowing in this branch. What would that value be? 2 times Vp, because Vx is equals to Vp, right? Plus, tell me, in this branch, what would be the current? It would be Vp minus 4 divided by what? Divided by 2 is equal to 0, right? Let us solve it for ourselves. Vp plus Vp minus 6 plus 2 Vp plus Vp by 2 minus plus, this would be plus 2, right? Right? Plus 2 equals to what? 0, right? Right? So this makes 4 times Vp, right? 4 times Vp. Okay, 4 times Vp, rather 5 by 2 times. Let us multiply the entire equation by what? By 2. Okay, so this would be what? 2 times Vp plus 2 times Vp minus 12 plus 4 times Vp plus Vp plus 4 equals to 0, right? 2 plus 2 is 4, 4 plus 4 is 8 plus 1 is 9 Vp, 9 Vp is equals to 12, minus 12 plus 4 is minus 8, minus 8. If you send it to the right hand side, what would it be? It would be, it would be plus 8. I'm repeating it. Minus 12 plus 4 is minus 8 on the left hand side. When you put it on the right hand side, it would be plus 8, right? So your Vp comes out to be what? 8 by 9 volts. But the question was asking us what is Vx, but we know Vx is equals to Vp, so our answer would be what? 8 by 9 times Vp. Okay? Okay? So, in questions, in questions, uh, in questions depend, on dependent sources, on questions on dependent sources, step number 1, identify on what variable is the dependent source depending upon. Okay, write it in the first step itself. Okay, and then solve the question simply. Solve the question simply as you were doing in the case of independent sources by replacing the values as given in, as we have found out for the from step number 1. If you replace it, it is a simple question, just as simple as a question based on independent sources. Okay. So, for tomorrow, we'll be taking a lecture on mesh analysis. Uh, I want you to read, you first have a basic idea of what exactly mesh analysis is. Uh, I want you to understand why it is not applicable for planar networks, why it is applicable only for planar networks and not for non-planar networks. Read it for once so that tomorrow you won't have any problem understanding. Okay? And what else? Tomorrow we'll be taking questions based on mesh analysis, and we'll try and begin with equivalent circuit also. Also try and do a lot of some questions, practice more questions, because only when you practice more questions you'll understand what question will have what approach. Okay. Equivalent circuits will have, star to delta conversion, delta to star conversion. These are some kind of questions that we'll be doing. uh, let's see. We'll try and speed up our course, because you will try and begin with EDC very soon. So because I saw your questions of past years for NET and JRF, and I did not find a lot of questions based on network theory. But only once you've done network theory, you will realize everything other than everything on your electronics is based on what? Network theory. You'll have to solve loops, and you'll have to solve equations there. So you need to be very strong on this. Okay? Beadstone bridge is also a topic. Okay. So let's meet tomorrow, and we'll try and finish off mesh analysis tomorrow. Okay? See you everyone tomorrow.